Hello everybody. So in this video we'll learn about a broad concept called frequency distributions. And you might remember from my first video that I said one thing that we do in the field of statistics is we take raw data. So here's some raw data, which is just numbers. It's an unorganized set of numbers. And our goal is to organize this and visualize it so that it's easier to understand and that we can make conclusions about it. Okay? So that's what frequency distributions allow us to do. It's a way to organize data. It makes it a little bit easier to understand. Now, I have some keywords that I want us to learn through the course of this video and the next one. And our friend, the stat cat, may be here to help us out a little bit. Okay? So there's classes, class width, class midpoints. All of these things we'll talk about through the course of doing some examples. One word that is a little tricky that I feel better talking about is the word data. Okay, so first of all, data is plural. Okay, and datum is singular. All right. So, for example, we might say these data are 1, 3, 5, 7, and 9. Okay, that's the plural use versus saying this datum is 9. Okay, now I don't really want to explain the difference between plural and singular besides showing you these examples, but maybe how about one more with maybe a word that we're more familiar with. So, cats is plural and cat is singular. So we might say these cats are named Walter and Donnie, but we would say this cat is named Maud, okay, for example. So data is plural, datum is singular, all right? Now, how about this? We need to learn these keywords and concepts, but let's just do that by way of an example. So the way I like to teach is just primarily through giving examples. So that's what I want to do right now. So let's take some raw data. We almost always start with raw data when we're doing statistics, okay? So here we see data that measure the time in minutes that 20 different people spent reading the news in a given day, okay? Now, why somebody would collect that data or what they're trying to study about people's behavior, that will be a little bit besides the point yet, but I just wanted to give something that's simple to understand. You know that people read the news sometimes. Some people spend more time reading news than others, and we could measure it if we wanted to, all right? Maybe we want to make conclusions about their habits and so on. Now, when you're doing your homework and so on my math lab, you might see a data set, something like this. In another video, I'll show you something that's part of my math lab that's called StatCrunch that will help you work with this. I mean, because if you just had to pick through all these numbers the way they are, it might be hard to do what we need to do. But StatCrunch gives you a way to sort numbers much easier, okay? Now, when we have raw data, there will be a certain number of numbers, okay? And that's called the sample size. So, they have collected data on 20 different people. There's 20 numbers here. The sample size is 20, okay? All right, now, what I'd like to do is construct a frequency distribution with 5 classes. Now, normally for a frequency distribution, we'll do between 4 and 10 classes. If you get too many classes or too few classes, it's hard to draw any conclusions from that, all right? But you won't have to worry about that. The number of classes that you're going to use when you make a frequency distribution will be given to you in the problem, so you don't have to worry about that number, okay? Now, in my frequency distribution, I want to include the classes, the frequency, the midpoint, the relative frequency, and the cumulative frequency. And by way of doing that, I'll show you what all those things are, okay? All right, now we have to find and calculate some numbers in order to do that, all right? But here are the steps for creating a frequency distribution. First, we need to find the range of the data. Okay, and the range is just the highest datum, the highest number, minus the lowest datum, the lowest number. Now, if you look through the data, you can figure out that 39 is the largest number and 0 is the smallest. Now, if you use StatCrunch, it'll make it easier to figure that out because you can sort the data from least to greatest. But the point is, we figure out the highest and the lowest numbers. We subtract them and we get 39, and that's the range of the data. From lowest to highest, the range is 39. Okay? Next thing we need to do is find the class width of the frequency distribution. Okay, now it's a little bit hard for me to tell you what this is without showing you, and I'm about to show you. Here's what the finished result is going to look like. All right, but we're not quite there yet. The class width of the frequency distribution is the range, which we found out here, divided by the number of classes, which was given in the initial problem. Remember, the initial problem says, can you make a frequency distribution with 5 classes? Okay, so there are 5 classes. The range was determined to be 39. We're going to use 5 classes. If you divide those, you get 7.8. But we always round this number up. So 7.8 will become 8, and the class width is 8. Okay. Next thing, we need to find out the class limits. Those are the lowest or smallest datum is the lower class limit of the first class. And how about this? Like, this is, I could explain what the class limits are, but it's just so much easier to show you that, you know, even though I wrote this, I don't think I'll go into it here. So, but once we do that, once we figure out the range, okay, the class width, the class limits, once we do all that, we make a tally mark for each datum, okay, and we count the tally marks to calculate the frequency. Now, again, I think these last 3 is just better to show you, all right? So here goes. This is the raw data before we did anything to it, and here is my frequency distribution, all right? Now, remember something real quick. We determined on the previous page that the class width is 8, and then the smallest datum was 0. Okay, so here's how we determined the classes. We start with the smallest datum, the smallest number in the data set, which was 0. And then we add the class width to that, and it gets us the lower class limit of the next class. So I'll do like 0 plus 8. 8 plus 8. 16. 16 plus 8. 24. 24 plus 8. 32. And if the next class begins at 8, that means the first class ends at 7. Okay? So, when I'm doing this, I'll find out these lower class limits. 0's the smallest datum, add the class width, 8, 16, 24, 32, and then I know this one goes to 7. So this one goes to 15 since that's 16. This one goes to 23 since that's 24. This one goes to 31 since that's 32. And if I were to have another class, this is 5 classes, right? 1, 2, 3, 4, 5. It said 5 classes. If I were to have a next one, it would start at 40. So that means this one goes to 39. Okay. Now, all right, so that breaks down the data, okay? Like 0 to 7 minutes reading the news is one class. 8 minutes reading the news to 15 minutes reading the news is the next class. Now, the next thing to get the frequency is we need to look through the data and figure out, well, how many people spent between 0 and 7 minutes reading the news? Okay? And we'd have to look through these numbers and say, well, 4 and 6 and 6 and 5. We have to count all those people that spent between 0 and 7 minutes reading the news, and there's a total of 6 of them that are like that. I counted through this. 6 is what I got. All right? Then we look at the same data set to get the rest. How many people spent between 8 and 15 minutes reading the news, according to the data? Well, if you count through it, there's just 1. How many people spent between 16 and 23 minutes reading the news? You count, there's 2, and so on and so forth. So that's what the frequencies are. Okay? Now, so far we've got the frequency distribution. I told you how to get the classes and what they mean. And that every class has a lower class limit and an upper class limit and a frequency. Now, there are some other numbers that we use to do other things, okay? For some things that I'll talk about later on, we might want the midpoint of the class, okay? So the midpoint for any class is the lower class limit plus the upper class limit divided by 2. So, like for this first class, to find the midpoint, the center, the middle of that class, I would say 0 plus 7 divided by 2, which is 3.5. To get the midpoint of the next class, I would take 8 plus 15 and then divide by 2, and that's 11.5. That's how I get the midpoint. All right? Now for relative frequency and cumulative frequency. Okay? Well, let's talk about relative frequency first. You can think of the relative frequency like a percentage. All right? You take the frequency for the class divided by the total number of data. And remember, the total number of data is the sample size. So what's the total number here? There's 20 people. There's data on 20 different people. There's 20 numbers. Sample size is 20. So the relative frequency is kind of like this. We'll say, well, there were 6 people that were determined to read between 0 and 7 minutes of news. Okay? But we could also say, well, 6 out of 20 read between 0 and 7 minutes of news. 6 out of 20. That's the relative frequency, relative to the entire sample size. Now, 6 out of 20 is 0.3. And so you could look at that like, well, for this entire sample, all 20 people, so 0.3, if I were to say that as a percent, what would I say? 30%. So it's like this number says 30% of the people read between 0 and 7 minutes of news. And then for the next class, 8 to 15 minutes, well, there's only one person, so that's 1 out of 20. 0.05. So like only 5% of people were found to read between 8 and 15 minutes of news. 1 out of 20 is 5%, okay? Now we would continue that for the others. It'd be 2 out of 20, 7 out of 20, 4 out of 20. We can convert those to decimals. This is 10%, 35%, and 20%. All right, so that's what the relative frequency is. Now, last, the cumulative frequency. You could think of that as like a so far number. This is how many so far. The official definition is the sum of frequencies for that class and all previous classes. So, in other words, like if I say, okay, from 0 to 7 minutes, we tallied 6 people in the data set. So 6 read from 0 to 7 minutes. Now the next class is 8 to 15 minutes. So if I say a cumulative frequency is 7, then it's like I'm saying 7 people were found to read between 0 and 15 minutes of news because there were 6 here and 1 there. So that's like 7 so far from 0 to 15, 7. And then if I say the cumulative frequency is 9 here, what's that mean? Well, from 0 to 23 minutes, it's found that 6, 7, 8, 9 people, see 6, 7, 8, 9 people read between 0 and 23 minutes of news. Okay, so you get the idea with the cumulative frequency. Now, maybe you can see this in a better light now. It's the sum of frequencies for that class and all the ones that come before it. So you're just like, this number, 16, is found from adding 7, 2, 1, and 6. Okay. All right. Now that takes care of a frequency distribution. Okay. Those are the basic ideas behind it. Now, I did tell you I was going to make another video, perhaps right after this one, or maybe if not right after this one, after my next video. But I'll show you how to use StatCrunch. That will really help you out when you have a large data set, because I can do all the math that I showed you with this, but it's kind of hard to just pick through the numbers when they're just scattered like that. StatCrunch will help you organize it. It'll help you sort through it. It'll help you see what you need to see to solve the problems.